solving quadratic equations when you have an x squared and you have an x term. So notice here we come upon an equation, we notice we have x squared and we have x. That means that it's quadratic, and we will either have to factor or use the quadratic formula to solve this. We hope that it factors because that sometimes is easier to go through than the quadratic formula. What you want to do first is we have to have a set equal to 0 in order to use factoring to solve it. So we want to get everything on one side of the equation. So here I would subtract 20x from both sides to move it so that everything is on one side and 0 is on the other. I have x squared minus 20x plus 100 equals 0. You may ask, why did I put the negative 20x in the middle? Just because that's the way we're used to seeing polynomials, is in decreasing order with their exponents. Normally the x squared comes first, the x comes second, and the constant, or the term without an x, comes last. For factoring, notice there is not a number in front of x squared. So my job here is to look at that number on the end, 100. I need factors of 100 that add to equal the middle term, negative 20. So are there factors or numbers that multiply to equal 100 but add to equal negative 20? So you would just go through the factors. Again, this should be review, but everybody can always use your review. The factors of 100, 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10. Okay, so there are some of the factors. Would any of those, could I find them to multiply to be 100 and add to be negative 20? Well, if I had negative 10 and negative 10, notice their sum is negative 20, but when they're multiplied, negative times negative gives me positive 100. So those are my two factors. So I go ahead and write down those factors, x minus 10 and x minus 10. So I have x minus 10 times x minus 10 equals 0. Our next step is to set each factor equal to 0 and solve. Here our factors are exactly the same. Okay, so we just get x equals 10 for both of them. So we have our solution of this problem is just x equals 10. Okay, so again, we noticed that we had an x squared and an x term, so we set it equal to 0, factored, set each factor equal to 0, and solve. Those are the steps for solving a quadratic equation by factoring. All right, here we have another example. Again, when we look at this equation, we notice that we have an x squared and we have an x term. So we know we can't just take the square root of both sides to solve this. We have to actually do factoring, or again, completing the square or quadratic formula if you're familiar with those. Notice this one's a little different. It's already set equal to 0 because that's my first step. It needs to be equal to 0. But notice I don't have a constant term on the end. When there's no constant term on the end, we're just going to use basic factoring principles. We're going to factor out whatever they have in common, the x squared and the 8x. And they both have an x. If I pull out an x, I would just have x plus 8 left over. It's kind of like distributing, but in the opposite way. We're pulling that x out rather than distributing it in. And you can check for yourself that if I multiplied that x back through, I would get x times x is x squared, and x times 8 is 8x. Again, may be review for you, but a review never hurts. These are the ones that tend to mess people up. Right, then, so we had it set equal to 0, step 1, check. We factored it, step 2, check. Our last step is to set each factor equal to 0. So one of our factors was just plain old x, so we have x equals 0. The other factor was x plus 8, so we have x plus 8 equals 0. This one is already solved, x equals 0. And here we just subtract 8 from both sides, and we have the solution, x equals negative 8. So there's two solutions to this problem, x equals 0 and x equals negative 8. Again, we're just going to go through some more examples of quadratic equations and factoring so that we can get each type that you might see. Right, here we have another problem. Notice it's quadratic. I have an n squared and I have an n. So again, I can't just use that fun way of just taking the square root. We have to factor if we can, if it's a possibility. So we make sure it's equal to 0, check. It's already set equal to 0. Then we look at that last term, 27. We want factors of 27 that add to equal the middle term, 12. And so you would just go through what are the factors of 27. Sometimes it takes a little longer to figure out what it might be. But notice 3 and 9. 3 plus 9 is 12, and 3 times 9 is 27. So there we have it. Write down our factors, our n plus 3 because it was a positive 3, n plus 9 because it was a positive 9 equals 0. Set each factor equal to 0 and solve. Those are our steps. Set the problem equal to 0, factor, set each factor equal to 0, and solve. Those are the steps for solving by factoring. N is negative 3, and n is negative 9. Two solutions again. All right, here's another example, and we want to look at it carefully and assess what we have here. I have an x squared and an x, so I can't take the square root. I'm going to have to try some form of factoring, and I notice that I just have an x squared and an x term. There's no constant term. Make sure it's set equal to 0, which it is, and then we factor. And again, for these, all we're going to do is pull out common factors. Okay, so we pull out an x. They both have at least an x in them, and we're left with 8x minus 3. Double check. If I multiplied that back through, I would come back to that original. Okay, we set it equal to 0. We factored. Now we set each factor equal to 0 and solve. So we have x equals 0 and 8x minus 3 equals 0. The x equals 0 is solved. The other, we add 3 to both sides, giving us 8x equals 3, and divide both sides by 8. And we are left with x equals 3/8 and x equals 0. There are our two solutions to this problem. Okay. These last two are a little bit different, and I'm going to show you, you will see why.